Now, I so far have done stuff with field elements, which is the parts of the field, really. I have to build this year the switch, the scale, and the exchange. I'm done with the exchange. The hardest part, I'd say, would be the ramp part of it, because it was hard to get the exact measurements and the angle right. At the moment, I have to do the scale, which we're not going to do a full-fledged scale. We're just going to do something that like hangs off of a door. And it's just like a platform that hangs off of a door, because it'd be easier than building a pole up from the ground. So I'm going to do that. And by we, I kind of mean me. I'm the only one working on field elements. I'm working on field elements because we need something to practice the robot on. Because say we build a robot, but it can't get on the platform after you're done with the match and you have to climb. If it can't get on the platform, then you kind of lost like 30 points. I think it's 30. I don't know. I don't remember exactly. So, and then with the exchange, just to get down pat on how fast we can do it.
How fast you can do what?
The exchange. How fast we can do the exchange.
Build it?
No, how fast we can exchange stuff through the exchange. Alright, so the field, at the moment there is the switch. There are two switches, one on each side of the field, and then there's a scale in the middle. Both of them give you the same amount of points when you have control of them. It's kind of like, I don't know, kind of King of the Hill, but with multiple points. And you get control of the points by having the most blocks on your side of the point. Power cubes, not blocks, sorry. And then there's an exchange in which you push a cube into it, and then that gives you 5 points, I think. And then you can either put the cube back onto the field after the exchange, or you can bring the cube over to the power-ups, where you can start charging up a power-up. Either levitate,
force a boost,
and that's basically the field. Otherwise, you have to climb at the end, so there's going to be a small, like, rod you have to grab onto. All three of the robots have to grab onto, unless you use levitate, and then only two of them do.
How far are you?
How far am I? I have finished the exchange, and the switch, it's really, you don't need to build the entire switch. You just need to build or find something that's the same height as the little edge over it, because the edge doesn't move its height. You just need to be able to get something over that height, which is easy. I don't know. And then the scale, what I'm going to do is I'm going to, instead of building up, I'm going to kind of hang it down from the side of a door. You're going to have something that goes around the edge of a door and then hangs down to the right height, and then a board's going to come off of it, basically. Well, it's going to be kind of a flat board. I don't know how big exactly. I don't remember off the top of my head. And then I'm going to have the lip or the edge come up like it is on the actual one. So this is the exchange. It's only the bottom part of the exchange because we don't really need the top. We're not planning on doing anything with it. So we just have the bottom part of it where we would push blocks in, power cubes actually. And the legs holding it up, very simple. They're just scrap pieces of wood that we screwed on to hold it up, because the back doesn't really matter. But then the hole we cut to be the right size, besides with this little wavy thing here that we should probably sand down. And then there's the ramp, which was harder to build than you might think, because getting the angle right is annoying. Like, especially getting two angles right. Because right here, from the side, you can see there's this piece and this piece. And this angle we had to get right to line it up with the ground. And these two, and this angle we had to get right to add to this, and to get it to be the right angle to line up with the ground. And then have this be flat on the ground too. So that was the most difficult part of this piece. Otherwise, it was a fairly easy build.
So we need this hex shaft.
You're not cold.
So I can get started on it.
Yep. And then when you get the hex shaft done, actually just start a drawing and throw it in a drawing right away.
Okay.
Because I think either I'm gonna have guys at work do it or Max is gonna do it.
No one can be cold. It's okay.
Okay?
Oh, they're gonna make it?
You're gonna make it. Alright. Then if who wants to work with the assembly here? And you wanna do that? So mount these bars to the outside and then make this part a little bit longer. And then also at the end of this, I'd say probably like 1 inch to the inside. We're gonna need we're gonna put a, okay, so this is how it's gonna go. I don't have the motor, but the motor was that little seat motor that we had here. It kind of looked like, yay. And it had the hex motor on the inside. This is where this square part's gonna go in, okay? So the motor slides on that square part and then the motor's gonna spin and turn the whole thing, okay? So we got the motor here. We're gonna have to make a spacer that's gonna get attached with a screw that's gonna go through the. There's a hole on the motor that's gonna go all the way through, and it's gonna get attached with a nut on the other side.
Yeah.
Wait, what was the statement?
Then on this hex shaft, we're gonna put a hex collar. That's gonna be in here.
I didn't hear
And
all
a
of it.
hex
I just
collar.
heard not really stupid, but stupid enough. So Jack, not really stupid, but you're stupid enough.
We have to. That'll be a purchase part, but it's a part that will bite on the bar so that if you have two of them, the bar can't slip out. It'll be trapped. And I'll try to find one of those to show you what it looks like once we get one. So in this is the arm piece coming down. So in the arm, we're gonna put one of these on the outside. So there's gonna have to be a hole big enough for this. So we're just gonna drill all the way through.
Pretty much.
On the end, it's gonna be
Well, you know, there was this point today where they handed me a motor
1.125
to figure this out, but I could find
diameter.
nothing online to figure it out.
holes that's gonna go on the end here. So you'll have to do that because since you're modifying it
Aside
anyway.
from a basic
And then I'll be
schematic,
about 1 inch from
but
the
that
end.
helped teach me how to hook it up.
And then
There are too many wires
the
on it.
clearance, and then we'll have another bearing on the other side with a collar on the other side. And then that'll spin, okay? So what that's gonna do is that's gonna spin, that's gonna allow the pinchers to move up and
Either
down,
max or you
okay?
can right disappear.
So
So I'm gonna blame
then,
God.
once we get this stuff
Not the cobalt?
on, I wasn't sure about doing the pincher yet, but you were working on the pincher assembly. So I don't know, maybe Simon should work on the hex and you should work on this.
On the pinchers.
On the pincher part, yeah.
Where should?
So we're gonna do, this is gonna be 2x1. So that means it's 1 inch wide by 2 inches long. Okay?
Mainly, this is true.
So it's 2 inch plus.
Do it. Do it, man.
2 inches this way, 1 inch this way. Okay? And then what's gonna happen is we're gonna have,
That's pretty cool.
Yeah, I told you you would check it.
we're gonna drill a hole in here.
But will I?
I think it's the same size, 1.125. And I think
In diameter or radius?
Only
in
really
diameter.
2,000 people
So I think,
understand. No, because that's so nice.
because we want,
Is it
so this
still
is
a
gonna
thing?
fit inside that hole,
How is
okay?
it still a thing? I don't know.
Yeah, 1.125.
I'll fix it in now.
And then, so this is gonna slip inside there, and then we're gonna have to have some 4 holes, right? And then, so you'll just have to measure this hole and match it, and then put that right, so this will go in there, and then you'll have to measure these holes and space it out.
Got it.
Don't tell me what to
And then this piece here, I don't know how long it's gonna be yet. Hold on a second. I don't know how long it's gonna be yet, but let's say maybe, let's just say 6 inches from now, okay? And then what's gonna happen is,
Well, I think somebody that's already on the CAD team should work on that head shaft.
so if this is the 2x, right? So this is 1 inch, and then 2 inches deep,
Maybe you
right?
should text her.
We're gonna put a piece of the,
I trusted her last night. She fed me in.
you know how you have that 1x1 now in the back?
Yes.
So we're gonna make that 2x1. So it's gonna be 2 inches wide here by 1 inch deep.
Yeah.
And it's gonna lay on top of these two, okay? That's how we're gonna orientate it for now. And then we're gonna bolt it with 4 screws.
Sure.
Just do the screws I've been doing all the clearance holes 0.25. That's for a quarter 20 screw. So yeah.
Sure.
So you can get started on this. Owen's gonna do the hex shaft. Hex shaft is gonna be a hex shape. Half inch is blue flats, so it's half inch, half inch, half inch, with a square on one end, and the square is going to be 1 inch deep. And this, there's a drawing here with the square. It says 6.05 millimeters. So I'm assuming it's square 6 by 05, 6 by 05. And so if you're going to do inches, we'll have to convert it. It's right there. Oh, 0.24. Duh. So 0.24 inches square. So 1 inch to here. And then let's make the whole thing like 14 inches long, okay? This hex part. Let's make the whole thing 14 inches long, including this 1 inch. And then if we have to make it longer, we'll make it longer. And then after you get that done, can you do a drawing for it? Quick. Okay. And then
We could do it without engineering.
you guys just want to
Yeah, we
watch
just have
me
to
and
really
help her
work
make
the
sure she
wire
gets
hole.
everything right when she puts the stuff back together.
I have a quick question.
Yeah.
So, do you want me to, those two arms on the inside, do you want me to put them on the outside or switch places with the outside one?
I want these on the outside of this because I want
So
this
I-
to be a bigger gap in here.
So you don't want to move them?
I don't want to change the green
Okay.
pieces at all.
Okay, got it.
We'll have to change the length of our port beams across.
Yes, these here. Yes.
Okay.
And then they're going to be working on. Max is working with me on the lead screw. Max, you're working with the lead screw, right?
What?
You're working with the lead screw,
Yeah,
right?
I know.
Okay.
Papers.
And yep. So we'll have to change these two pieces.
Okay.
I don't know why you're mad at me.
If you want to take turns and one person modify this, but you'll have to work kind of in here.
Yeah.
So, all right. And if you have questions, just ask, okay? Because it's a lot. And once you get these arms done, and he gets the hex shaft, can assemble the hex shaft in here, and then I'm gonna actually take one of you guys, and we're gonna go see if we can find what we have for hex collars here.
Leo.
All right.
Okay, so electrical is where we run all the wiring for the robot and we crimp like power poles so that all the wires on the robot can get plugged together like this, and then they're connected. So we have to wire up all the controls of the robot. So there's like a brain, and there's motors and motor controllers, and they all get connected to create like the controls of the robot. And so some tools we use is heat shrink to cover up wire joints. We have soldering irons, we use wire strippers, wire cutters, and that's most of the tools we use.
Yeah, let move the box in.
Okay, let me reverse the polarity.
Ready? Out. Ready,
Out.
Turn it on.
That's what the boxes look like?
Yeah.
Yeah, it's a power cube.
It's
Not a box, it's
Ready?
a power cube.
It's a milk crate with wrapping.
Now let's try it.
Let's get a chain of them and just send them through.
So get it crooked, you're
Okay,
saying?
go.